Hello everyone, I'm Preeti and I'm here to present the findings of our research on the comparison of reading versus tutoring to teach novices to better comprehend introductory programming concepts. And the comparison of the two strategies is mainly based on students' self-efficacy. Here's the outline of my presentation. I'll begin with the motivation of the study and then briefly talk about code comprehension for novices and then about self-efficacy. And then I'll focus on the research question, experiment design, content, the system description, and the key findings of our study. In the current scenario of CS education, there is a disproportionate focus on code writing as compared to code reading. By prioritizing on code writing as compared to reading, students might miss out on the opportunity to develop deeper understanding of programming concepts, strategies, and technique. Research suggests that programming skills can be better developed by first mastering the fundamental of code comprehension and then moving on to the complex task of writing code. And as self-efficacy has direct influence on learning, we're trying to see how it affects code comprehension strategies among novices. Code comprehension is the process of understanding a code example through which an individual constructs the mental representation of a code. It is a crucial skill for both novices as well as professionals. So how do we foster this skill among novices? One simple way would be to provide novices with supplementary reading material with code and its corresponding explanation. Simply put, we encourage them to read more code example. But since reading is a passive strategy, will it be beneficial for all the students? We propose an alternative strategy through tutoring using our system, which employs scaffolded self-explanation technique. And we use scaffolded self-explanation because it has been proven to be an effective strategy in computer science as well as other domains. In our study, we analyzed the effect of these strategies based on individual self-efficacy. Self-efficacy is people's judgment of their capability to organize and execute courses of action required to attain designated type of performance. Prior CS research has found that prior knowledge, programming experience, mental model, and confidence to be some of the factors that influence self-efficacy. And the relationship is both ways in the sense that self-efficacy influences mental model and confidence. Self-efficacy is an important factor for students' performance because as self-efficacy increases, students' academic performance also increases. Our first research question is to find whether there is any difference in reading versus tutoring through our system of scaffolded self-explanation to improve students' code comprehension. We also investigate if self-efficacy affect code comprehension when using the two different strategies. For this, we conducted a randomized controlled trial experiment where we randomly assigned student to control group where their assignment was to read code examples and another group we assigned another group of students randomly to experimental group where they interacted with our tutoring system which was about scaffolded self-explanation. I'll explain about our tutoring system more in detail in the later. Students in both the groups were exposed to equivalent content, and we measure the effectiveness of the two strategy through normalized learning gain through the pre and post-test analysis. In our experiment, we mainly focused on intro to programming concepts like logical operator, if-else, loops, arrays, classes, and methods. As per the content as per the target material for code comprehension, we used LeetCode CodeSet, which was developed by our research team with the focus to teach novices code comprehension and is mainly focused on the introductory concepts. The code set was developed on the theoretical foundation of code comprehension and self-explanation. As you can see on the example on the right, the code examples are focused mainly on relatable real-world example. For example, this code here checks whether a year is a leap year or not, and we use this example to teach the concept of ternary operator in Java. Each example in Deep Code Set focuses on single concept and the concepts build up progressively. For the explanation, First, the code is decomposed into major logical blocks, which is separated by white lines. And then we provide the logical step and logical step details, which correspond to the domain model and program model of the code comprehension theories. The logical step may also have the integrated model, which is the linking between the domain model and program model, or the link between the logical step and the logical step detail. Each of the logical step detail also has scaffolding questions which serve as a hint to student in case they need it. So this is the user interface of our tutoring system, which we refer to as DeepCode Tutor. At the top right, we have the task and code description, which is highlighted in red, as you can see in the figure indicated by the letter A. Right below the description, we have the code editor that displays the code example as indicated by the letter B. On the bottom right, as indicated by the letter D, we have the text box that allows the student to enter their response. And right above the text box, as indicated by the letter C in the figure, we have the dialog history. At first, we ask the student to freely self-explain the code in as much detail as possible. Once the student provides the response, we assess the student's explanation on two different criteria, completeness and correctness. The student's response is assessed by comparing it against the benchmark explanation, which is the explanation that is provided by the experts in the DeepCode code set. The comparison is done by the use of different semantic similarity approaches. If the student's answer is complete and correct, then the student moves on to the next task, and the system provides the summary of the correct explanation. If the student's answer is incomplete or incorrect, then the tutoring system provides scaffolding for the incorrect or incomplete part of the student's response, and the student is again asked questions on the incomplete or incorrect part. And the student provides answer, and the process continues until the student provides the complete and correct answer. If even on multiple attempt a student doesn't provide complete and correct answer, then the tutoring system just provides a summary of the expert explanation, and the student moves on to the next task. So this is the summary of how our system interacts and how the system works. In this particular example, the question is on the first logical step, which is about variable declaration, and the questions are based on the first logical step. For our experiment, we recruited participants enrolled in introductory Java programming course in a large public university. We conducted the experiment towards the end of fall 2022. We recruited 90 participants and we compensated them for their participation. 89 of them completed all the tasks, among which 47 were randomly assigned to the control group and the rest were assigned to the experimental group. 14 of them identified themselves as non-native English speakers. We found that the students were enrolled in different majors. Apart from being enrolled in computer science, they were from different majors like data science, computational biology, or digital narratives. For the instrumentation of self-efficacy, we used the instrumentation proposed by Axer and Davenport. The participants demonstrated a high self-efficacy for all the intro to programming concepts as seen for item below 4. The student had the highest self-efficacy and conditional expression as underlined in blue in the figure, and had the least confidence about the mastery of the concepts, all the Java concepts taught in the class, as indicated in the figure in the color yellow. Here's the so as we can see in this table, most of the student had a high self-efficacy, which was above 3 for in average. So Here is the distribution of the pre-test score for all the participants and the self-efficacy score for all the participants. And the distribution clearly indicates that our sample is biased towards high prior knowledge and high self-efficacy student. We also did a quick correlation analysis on the relationship between the prior knowledge and self-efficacy, and we found a moderate correlation of 0.45, which indicates that the students were good at self-reporting their self-efficacy. So on the impact of tutoring on learning, we found that the learning gain in experimental group was slightly higher as compared to the control group, but the learning gain was not statistically significant. Also, the effect size was a very small value of 0.19 in the favor of tutoring system. But again, this is not a statistically significant value. So we can say that in general, both strategies were beneficial to the students. On the effect of self-efficacy on the two different instructional strategy, we found that students in the experimental group who used the tutoring system had almost the same learning improvement in both low self-efficacy as well as high self-efficacy students. Whereas the student with high self-efficacy in the control group had twice the learning gain as that of the student in low self-efficacy student, which suggests that students with high self-efficacy might beneficial more from reading as compared to student with low self-efficacy who might need more scaffoldings. Overall, the students with high self-efficacy had higher learning, irrespective of the strategy, irrespective of reading or tutoring. Since 35% of our participants were non-CS major, we also did some comparison on the CS and non-CS majors and found that CS student had significantly higher prior knowledge and self-efficacy as compared to non-CS student. CS measures also had twice the learning gain as compared to non-CS major when in the control group when reading the annotated code examples. Whereas in the experimental system, CS measure also demonstrated higher learning gain as compared to non-CS major. Overall, CS major had higher learning when reading the code example as well as when interacting to the tutoring system. I would also like to highlight one particular item from the user feedback survey. We found that most of the participants of our study did not find the task to be challenging enough, as shown in the response from one of the questions from the user feedback survey. This could be possibly because we had the sample which was biased towards high self-efficacy and high prior knowledge students. Prior research by Van Lee, which compared reading and tutoring, found that when intermediate learners are given intermediate difficulty tasks and novices are given tasks at their difficulty level, the learning in an interactive condition is similar to that of reading. So this could have contributed to the lack of difference in learning gain between the control and experiment group in our study. So in our future work, we would like to do the same experiment with more challenging code examples. And as a future work, we'd also like to analyze student self-explanation using more advanced techniques. And also would like to have a post-hoc analysis of the self-explanation of students based on various other factors. Thank you.